Okay, so this is
Yes.
lesson 4 in our space travel and exploration camp. Welcome, Julia.
How are you? Good morning, everyone. Okay, let me get these ready. All right, so, sorry. Spoiler, I was trying to, let's see if I manage to have you all with me on a page so I can see who is raising hand and wants to, talk. Okay, hopefully I can see everyone. All right, so this is lesson 4. We are getting towards the end of the summer camp. And today, what are we going to do? So first of all, what we did yesterday we look at our solar system. We look at how we can study distant planetary objects. So how we can go to, let's say, Mars or to the moon or even farther away. Patrick mentioned the Voyager spacecraft, which is a spacecraft that now has left our solar system. It took 45 years. Imagine, it was launched in 1977, if I'm not wrong, and a few years ago managed to cross, let's say, the border of the solar system. Is now traveling in interstellar space. As we said, our solar system is quite big and huge, long distances. It takes a long time. So today, can you hear me all? Maybe today I have a bit of internet issues. So just let me know if you're missing something.
Yeah, you're
I'm saying,
okay now. You were breaking up a little bit.
Okay, so, and okay.
It was
great. Just let me know. Sorry about that.
It was me,
So
and
yesterday,
the computer was updating, and it just started updating.
okay. So I hope now is okay, Oscar. Are you ready with your computer
fine.
now? Okay, cool. Just let me know if anyone is missing something. I can, make sure I will repeat. All right, so yesterday we mentioned spacecraft, okay? And landers and rover. So today we are going to look at different type of space missions, and we will see what we mean with that. And then we will finally look at how we can land on another planet, okay? And how to choose where to land. As I said yesterday, we are going to watch some videos, 2 videos. So I hope you will enjoy. And so in a bit, shall we get started? Yes, I'm gonna say yes for you all. Okay, so spacecraft. We mentioned, as I said, spacecraft yesterday is the way, how we're, let's say, transport, okay, to get closer to a planet. And do you know, guys, how we send spacecraft to space? How do we send a spacecraft to another planet? You maybe have touched this with Jack in the first 2 lessons. Okay, who is having? Patrick.
So they send a spacecraft there with an explosion, and it all depends on how the rocket works.
Okay, so you say rockets. Did I hear correctly?
Yes, you heard correctly.
Okay, so that's great. So here in this image, can you all see the rocket, a rocket?
Yes.
Yeah? So it's actually in the taking off stage. You see the big fire of the propulsion, okay, the fuel, and creating this immense thrust to lift the rocket, to escape the Earth's gravity and send our spacecraft into space. But do you know where in the rocket here, where is it? Where is our spacecraft? This rocket won't be reaching the planet. Owen, I see you have maybe something to say.
Would the rovers or satellites be around near the top of the spacecraft?
Exactly, is at the top. So we have different type, let's say, of systems, okay? When we have a rocket, we mention the thrust, okay? We call it propulsion system. it's full of fuel. Usually we mix oxygen and hydrogen and maybe some other things to create this, let's say, controlled explosion to thrust our rockets out of the gravity, Earth gravity, okay? And so be able to escape Earth gravity and go to space. But then this is not enough, okay? We need to know where to send our rocket, okay? We cannot just say, you go and let's see where you end up. We need to know, we need to give the rocket direction. Do you know how the system is called to be able to, let's say, guide our rocket to the destination? Anyone has a Arav? I can see you have your hand up.
Is it programming?
It takes a lot of programming because you need to tell the computer, you know, you need to give the computer the instruction, the route. There's a lot of programming, and the system is called guidance, okay? There's a lot of programming, you're right. And you need to make sure you do everything right if you want to go to the right planet and not missing it. There have been some, well, unfortunate situation where using the unit or measure of meters, someone who was programming used the imperial unit or measure, like in miles. And so there was a big confusion, and I don't remember the name of the rocket. It was supposed to head to Mars, and he completely missed the planet. So you need to make sure you write your program perfectly, spotless. And as Owen said, we have what is called payload system, is at the very top of the rocket, and that's where we have our spacecraft or rover, if we have a rover in our mission, okay? It's up there in the cone of the rocket. When it's in space, the cone open up, and we have our spacecraft ready to head towards our destination. Okay, so we have a look at rockets, because we can have different type of mission, spacecraft and possibly a rover, okay? But we have different way to, let's say, get closer to a planet, okay? Yesterday we mentioned orbit, and orbit is a path of an object around another object, okay? We said planets are orbiting the sun. In the same way, we can place a spacecraft in orbit around it, okay? It's here on the right. Can you see this dashed line with an arrow, okay? That is going around the planet. So when we enter a planet's orbit, it's a kind of complicated maneuvering as usual, but you know, top engineer are able to do all this calculation and math, okay? So entering orbit of a planet allow us to constantly monitoring the surface of the planet or whatever other type of measurement experiments we want to do from orbit, okay? So we constantly, continuously gather information about the planet. And this is great. We have very long lasting mission, like 10, 15, 20 years orbiting around Mars, for example. And these are so fundamental to get to know the planet much better. But then we have other type of mission, a bit of like quick one, and they're called flyby. So as you can see here, the dashed line doesn't go entirely around the planet. So the spacecraft doesn't enter the orbit. It just goes very close to the planet and then continue on, okay? Can you see how this is supposed to be the trajectory of the spacecraft? Does anybody have any idea why the trajectory is bending? This might be a tricky one. Let's see if someone, okay. We have Patrick first, and then we go with Owen. And let's see if we have a correct answer. Patrick.
It is very close so that I can gather more information. And I also want to say something about the orbiter mission.
Please.
The orbiter mission might be a bit bad because it's just a waste for all your fuel.
That's right. You need to use a lot of fuel. Okay, cool. Let's remember what Patrick said. I'm going to ask you something else later. Owen, you had an idea or you want to say something about the trajectory?
Yeah, when they fly by in a curved way so they can get lower to the planet, so to either collect more information or to possibly drop a rover onto the planet.
Yes, exactly. You wanted to say something else? Okay, exactly. So when we go with a flyby, we go closer and you can see the trajectory is bending. And this bend is caused by the gravity of the planet, okay? The planet has a big mass. And so the bigger it is, the more will, let's say, bend the trajectory of our spacecraft. So this is a short opportunity we have to take photo of a planet, okay? We just have, let's say, a brief moment. We won't be able to observe the entire planet, but this is a very important way using the gravity of our planet or a planet to change the trajectory of our spacecraft and actually accelerate it, okay? So usually flybys are used by missions like the Voyager mission that Patrick mentioned, but many others, to be able to reach far away places in our solar system by using the gravity of other planets. So it's called actually gravity assist maneuver. Okay, so we exploit the gravity of other planets to accelerate our spacecraft. And as Patrick said, he mentioned fuel. We need to be very careful not to run out of fuel. So if we use gravity of other planets, we can save fuel for other type of maneuver that we may need further on in our mission. Okay, is it kind of clear? Would you, if you were a mission manager, mission plan manager of NASA, would you plan a flyby mission or an orbiter mission? Okay, you need a lot of money. I can see Owen. Yes, you need a lot of money to plan a mission, to have a lot of fuel. Who wants to? Patrick.
I would do, if I was a person in NASA, I would do 3 and I would do 15 orbits and then go back.
Okay, I can see. Okay, you will decide to come back. Fair enough. Anyone else would have other idea about?
I do a flyby.
Flyby, okay, flyby. And you will do a flyby to maybe reach far away object? Like farther distance in the, which one would you go back to Pluto or even farther away?
I'd go to Jupiter.
Nice.
And I'd try and get the flyby so we'd come closer to the Great Red Spot.
Oh, that's a beautiful, everybody knows what is the Great Red Spot on Jupiter? Yeah, it's beautiful. Talking about Jupiter, there's a really new mission, NASA mission, it's called Juno, Juno. I think he just arrived to Jupiter and he has been sending amazing images of one of the, I think the first images of Ganymede, one of the Jupiter moon. So guys, let's just keep an eye on Juno mission. He will send amazing images of, of Jupiter its moon, and as Hebe said, like probably the giant red spot, this massive probably storm that has been going on for more than 400 years on Jupiter. Okay, so we look at how we can use gravity, remaining in orbit with spacecraft, but Owen also before mentioned rovers, okay? And this is something also we mentioned yesterday, rovers and landers. This is our way to get to the surface of a planet or a moon. In this case, we are looking at Mars, okay? So these are called robotic mission, okay? Not you, we still don't have humans being able to touch the ground on Mars. Hopefully very soon humans will land on the moon. So yesterday we mentioned rover and landers. Do you remember what is the difference between the two different type of robotic mission, rover and lander? I can see Patrick and Owen again. Shall we start with Owen and then we go to Patrick this time?
A rover has wheels, so it can move around the planet, but a lander just lands and then it can't move.
Exactly. Patrick, you had anything else to add?
So the difference between a rover and a lander is that a rover has wheels and it moves, but
Okay.
And it stays on the planet and moves there without being picked up. But a lander has to be picked up after it lands. And
Yeah.
it can't move.
Okay, great. So we know the difference between rover and landers. Yesterday, we saw this image of Curiosity, okay? Curiosity landed on Mars in 2012. And yesterday, we mentioned a Chinese mission. This is very recent. China landed their rover Zhurong last April. So it just really soon arrived on Mars. And these two photos we have here, Curiosity and Zhurong, these are real photos taken from Mars, okay? Curiosity has a robotic arm and is taking a selfie, as we do with our cell phone. Is able, or she is able, to do it with a robotic arm. Zhurong instead, it doesn't have a robotic arm. It's somehow a bit more simple than Curiosity, but what it did, he moved a bit, he placed the camera on the ground, he went back and took a photo of itself, the rover, and the platform you see here to the right that used for landing, and then using the wheels, it went down. I think it's amazing. So here to the top instead, I don't know if you ever heard about this NASA mission. It's called InSight. InSight is a lander. Harav, I can see you have something to say. Have you ever heard about InSight mission?
I saw it take off on the TV.
Okay, good. So InSight is a lander, okay? As Owen and Patrick said, lander just land and they don't move. So why you would choose a lander over a rover if you can have wheels and go around? Sometimes you want to do experiments that requires your robot to stay on the ground without moving. And these, how to say, bulge here, this instrument here, you can see, okay, this kind of dome. This is a seismometer. Do you know what is what is a seismometer? Anybody knows what is a seismometer? Okay, I can see someone saying no. Patrick, maybe you can help us.
Seismometer measures how much sight, I think.
Okay, so size. We can say size seismometer. Meter is something that is measuring, okay?
So,
Usually
a size meter, something that measures something's size.
size or seismo. Okay, seismo. Okay, let's see what seismo means. Seismo, let's say, means shaking. Okay, so a seismometer is measuring, in this case, Mars quake. Seismometer on Earth are measuring earthquakes. So it's measuring how the ground is moving and shaking. Okay, so this InSight rover is just, it stays there, it doesn't move. It is really important for the landers to be absolutely standing still, okay, and be able to detect even small seismic shaking of the surface of Mars. What do you think can cause seismic shaking on the surface of Mars? I think these are really cool experiments they are doing. Patrick.
So they could detect earthquakes as small as a centimeter or millimeter, maybe even smaller.
Yeah, okay. I remember yesterday, I think it was Oscar. Oscar mentioned a couple of times like big impact, asteroid crashing into planet. Okay, Oscar is on mute. But so big impact, but even small impact. You remember, Oscar? You mentioned like asteroids crashing onto Earth, or hopefully not on Earth, but you know, somewhere else. So we have also, let's say, meteorite impacting any other planetary bodies in the solar system. And sometimes this impact happen on Mars. And so imagine something relatively big crashing onto the surface is able to generate some shaking, okay? And so the InSight lander will try to detect any type of shaking of the surface of Mars and try to understand the origin. Oscar.
I heard that there used to be water on Mars.
Oh, yes, there used to be water, and possibly, well, water is still present on Mars, but not in the liquid form. It's in the solid form that we call ice in the North Pole, South Pole, and getting closer is sometimes present as permafrost, which is the ice that frees the ground. So this type of instrument, InSight, is not really, it's not looking for water, but by reading the signal, he might be able to say what type of rocks are forming the subsurface of Mars, and maybe say something about presence of some sort of fluid. Okay, so we have been talking a lot about Mars, you know, of landing rovers and landers on Mars. But do you know if NASA or the European Space Agency or any other space agency like the Russian, or back in the days were called the Soviet Space Agency, do you know if, let's say, humans, whatever is the country, whatever is the space agency, humans were able to land a robot somewhere else than Mars? So we know we land on the moon, we landed on Mars with robots. Any other idea? Do you think we managed to land other robots somewhere else? This is a tricky one. Okay, we have Patrick, and if someone else has then other ideas, please, I want to know. Patrick.
I heard there was a probe that landed on the moon Titan.
Yes, okay, Titan. Let's see, I can see Fionn first, and then we go to Evie. Fionn,
Is there a robot on Saturn?
Okay, on Saturn, there was a orbiter, and it was called Cassini mission. He sent back amazing photos. But you were right, Cassini had a lander attached that then dropped, and it was called Huygens. And this lander landed, as Patrick said, on Titan. And Titan is a moon of Saturn. So Fionn, you were also correct. It was around Saturn. But Saturn, remember, we said, is a big gas giant. So it's made of gas. So we are not really able to have a solid ground where to land something. And Ibi, you still have your raised hand?
Some people landed more than one
Yes.
rover on Jupiter.
On Jupiter. Okay, so again, Jupiter is a big gas giant. So we cannot really land on a solid surface. We will just go into the thick atmosphere. And before he will touch the solid nucleus, we will lose contact because of the high pressure. But you are right. People are thinking to send a spacecraft around Jupiter, which is not Juno, is another one, but to land on one of the Jupiter moons. And I think NASA has approved the next mission. It's called Clipper, to land on Europa, which is one of the Jupiter moon. So I'm really looking forward to it. It's going to be fantastic. So there we go. These are my answers for you. Patrick and Fionn mentioned Saturn, and Patrick mentioned Titan. Okay, Huygens is the name of the lander, and look, he managed to send a photo of the surface of Titan. Titan is an incredible place, okay? And long ago, in 1982, well, actually even before, the Venera 14, but I think already Venera 9 or 10, landed on Venus. And these were a mission by back then was called the Soviet Union, which is now Russia, okay? So they send gigantic landers on big and sturdy, because the atmosphere is so thick on Venus. They have to be able to resist the pressure, otherwise crashing the spacecraft. And it's also very hot on Venus. Anybody knows how hot it is on the surface of Venus? It's like more than 400 degrees. So you melt like so you managed to survive about 40 minutes, 40, very short mission. But they managed to send photos. Philae, you pronounce Philae, okay? Hibi, you have
Can I ask you, would you mind repeating what you said? Would you mind repeating what you said about the landing there? Because you were a bit broken up.
Oh, well, I think Julia is breaking
I'm
up.
so sorry. Okay, I will. Okay, so we have. Is it my? Oh.
Yeah,
Okay.
I think you're
Can you
back
hear me
now. Your camera is a little funny. It kind of zooms into your face. Like, to me, I don't know if it's the same happening
Oh.
for everyone, but it kind of zooms into your face and then it feels like you're a meme. Oh, is she gone? No. Did it happen to you guys as well?
I'm
where
back.
like
Can you
you
hear me
see
now?
her face like very close up.
Oh gosh, I'm
I can
sorry.
hear you
Hope I didn't
fine
scare
now.
you too much.
Yeah.
Okay. Okay. I'm going to share again. And yes, I think Hibi was asking me to repeat. Okay, let's see. Okay, we were talking about landing a robot, okay, somewhere beyond that is not the moon and Mars. And so we said that the Huygens mission landed on Titan, which is a Saturn moon. And then we have the Soviet, which are now the Russian. They had a space program called Venera, which was their space mission to Venus. And they managed to land this really big lander robot that had to survive the high pressure and temperature on 30 degrees, so it can melt metals. So this lander managed to survive only 40 minutes, but still they had time to send a couple of photos back to us. And then we have in 20, there was incredible mission to a comet. And, you know, a comet is just traveling through space. So there was a chase, okay, with a spacecraft. Am I still breaking, Marie?
You could try turning off your camera just for like 5 minutes, and then if it stabilizes, you can turn it back on.
Yeah, maybe I can try this. Yes. Where is it? I'm going to stop video. All right, let's see if it goes better. I'm so sorry about that. And yes, so we managed also to land a small robot on a comet. Incredible. Okay, I hope you guys. Oh, it's a bit annoying. I'm so sorry. Are you all there now? Still?
Yeah, we can hear you fine now.
Okay. Okay, great. So now it's time for a couple of videos. Okay. So we have been talking about landing, and now we are going to see how actually NASA, these are video made by NASA, had their landing system. Okay. Oh, sorry, I forgot actually to mention something. I can see here I say soft landing. Okay, so we talk about soft landing and hard landing. Does anybody know, have any idea what is?
So anybody knows the difference between soft landing and hard landing?
Is it? Okay.
That's a difficult one to guess, maybe.
I can try to.
I have my hand up.
Oh, sorry, I didn't see. I can't see you guys because I'm
I'm so sorry,
recording.
Patrick, because
Sorry.
everybody was frozen for me. Yeah.
So soft landing is with the parachute and also some rocket boosters.
Okay.
And
Yes.
the hard landing is with no parachute and no boosters.
Yeah. So what happened when you have no parachute and no booster and you're approaching a planet at very high speed? What do you think can happen? when you have no way to slow down. Harav, I can see you have your hand up.
The ship will
Yeah, I can see someone mimicking. Harav, sorry.
the ship would probably explode.
Oh yes, it will explode. And I could see Sean doing, oh, okay, you don't have my video. Sean was mimicking, and I think a trajectory. Sean, can you do that again for all of us? Whee! And I guess that would be the sound, as Ara said, also exploding. Yes, no parachute, no booster. There's no way to slow down our speedy spacecraft. And of course, it's going to crash. And that's what we call politely, not crash, but hard landing. So a hard landing is when you're not able to land anything like your spacecraft or robot safely. And so you are going to cause damages to your robot, okay? Whereas with a soft landing, we control how we land with parachute and booster, and so we call it soft. So there's no damage to the instrument, and we can continue with the mission. All right, so what we are going to watch now is a video. This is a illustration, okay? This is not real space. It's going to look like real, but it's not, okay? I'm gonna start now. You may hear some sound from time to time. So here we are approaching Mars. You can see now the spacecraft enter the Mars atmosphere, and the friction of the spacecraft with atmosphere is creating heat. So we need a heat shield. Patrick mentioned parachute. We deploy parachute to slow down, but we are still approaching very fast, okay? So we need something more. Okay, we can remove the heat shield. We don't need it anymore. We can lower our robot, which in this case is, let's say, envelope in a bag, and boosters to even slow down a spacecraft. Now we can just cut the cable and let the space bouncing. We have a reduced gravity on Mars, so things will bounce for a bit, okay? So what we are watching here is a video that simulates the landing of Spirit and Opportunity rover, which landed on Mars in 2004, I think. Then you deflate your balloon, and then you open up your cage, and inside you have the rover. Yesterday we mentioned for satellite the importance of solar panel, okay? Because they power up our robot, our instrument. And so we have the opening of the solar panel. What also we need to raise the head of the rover, which is usually, is the eye of the rover. So they have camera, and that's it. And this was one of the way to land a rover. These were kind of 1 meter, maybe big rovers. This is called entry, descent, landing. So entry, we are entering the Martian atmosphere, with the burning, the friction of the gas with the spacecraft. Descent, so we are getting closer to the surface, and then landing, touching the ground, okay? We are going to watch now another video. I think this is even cooler.
Julia, do you want to share your computer's sound with us as well? No?
I think, yes. In this case, yes.
Thank you.
Yeah,
the other one was just like not much of in the audio, so that's okay.
So now I will talk less, and we will follow basically the final 2 minutes or so of the landing of perseverance. Probably put the accent in the wrong place. I'm so sorry. I think Arab, you pronounce it correctly. You mentioned that yesterday. Perseverance. Yes, there we go. Maybe you watched this video already. I don't know. This was back in February. Okay. So as we said yesterday, perseverance is much bigger than all the other spacecraft that NASA is landing. So being bigger, what do you think we need to change? Do you think those airbags that we saw in the previous video will be enough to land safely something bigger? Okay, I can see people, okay, doing, no, you cannot see me. Anyone knows how NASA has changed the way to land? So substituting the air balloons with something else. Patrick maybe has an idea.
So they use the air balloons, they use the parachute, but they also use something to, so they also make some explosions of the rocket to slow it down. So because the explosion is working to push it up.
Yes. So again, fundamental, we need parachute, okay? They have to be super strong to, slow down the descending spacecraft, but it's still not enough, okay? We need this booster. They're called retro rockets. So you fire your rocket towards the ground, so to slow down your spacecraft. But then we said the air balloon won't be enough to protect such a big, like 2 meters, like it's a small car rover. So NASA came out with another idea, and it's called sky crane. So instead of the air balloons, in this case, the rover is lowered down with a series of cables, really strong and sturdy cables, okay? Together with the retro rockets, slowing down the descent. And as soon as the rover touched the ground, the cable are cut. And the sky crane system is just move away, safely crashing away from the rover. Okay, are you ready to watch this amazing video? Okay, let's go.
I'm ready.
Good. Oh, I'm gonna start from
kilometers above the surface.
Okay.
The entry balance masses in preparation for parachute deploy and to roll over to give
There
the
we go.
radar a better
Parachute
look at the
deploy.
ground.
Remember, these are real images, okay? This is not an illustration anymore.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 430 meters per second at an altitude of about 12 kilometers.
Now we are looking down. The heat shield
up.
is released.
Perseverance is now slowed to subsonic
So we are
speeds,
looking
and
down
the
at
heat
the
shield has been
surface of
separated.
Mars now.
This allows
Okay.
both the radar and the cameras to get
You
their
can see
first look at the
heat
surface.
shield
Current velocity is 145 meters per second at an altitude of about 10 kilometers.
Can you start recognizing maybe some craters on the surface of Mars? Maybe it's still a bit hazy, but we are getting closer. You can see how the spacecraft is moving around. Oh, I can see maybe something like a linear feature, like bigger craters.
Nav filter converge. Velocity solution 3.3 meters per second.
We are
Altitude
reducing the
7.4
speed,
kilometers.
okay?
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers.
Okay, we are getting closer to the surface. We can better
Perseverance is continuing to descend on the parachute.
Feature of Mars, okay? We still have the parachute.
The initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2
we are still 4 kilometers high. So we need to get closer to the surface and further slowing down.
We have confirmation that the lander vision system has produced a valid
and now we have the computer trying to find where to land, okay? Like a safe area.
We have timing of the landing engines.
And now soon you will see. Okay, we're getting
Current
closer.
velocity is 83 meters per second at about
See,
2.6
all is red, it's a
kilometers
bit
from the surface
dusty.
of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver.
We are trying to
Current velocity is
find
about
a nice
75
place
meters per
where to
second at an
land.
altitude
We
of
can
about a
identify,
kilometer
look,
off the
boulders
surface of Mars.
on Mars. We are getting
Kieran, 50
closer.
Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second.
Now we are
altitude of about
only 300 meters from
off
the
surface
ground, okay?
of
We are
Mars.
getting closer, faster and faster. You see
We have
now
started our constant
the rocket's
velocity
effect on the
according, which
ground,
means we are
moving
conducting the sky
the
crane
dust. To
about
the
to conduct
left,
the
we
crane
have
maneuver.
on the bottom, you see the cable
Sky crane maneuver has
lowering
started.
the rover. To the top, we are
We're
looking
20
up,
meters off
okay?
the surface.
As soon as the rover, the wheel touch the ground, the computer, like a good programmer, says, cut the
Tango
cable,
Delta.
and it flies
Touchdown
away.
confirmed. Perseverance safely on the surface of Mars, ready to begin
Okay.
seeking the
I
sands of
just want
past
to show
life.
you my face. Every time I see these videos, like, wow, this is amazing. I mean, this is such a complicated, you know, engineer achievement. You see the cable, so we don't use air balloon anymore, but we are able to direct where to land, and on the moment deciding using this rocket, moving the spacecraft to find a safe place where to land. Okay, we have been talking about, oh, I want to change. Okay, there we go. But I guess before finding a spot where to land on Mars, we need to look at the entire surface of Mars. Okay, so this is the surface of Mars on a paper. Okay, Mars we know is a sphere. So when we make a sphere onto a 2D paper, that's how you, and where to consider where to land on Mars. Who do you think are the important people, like role, who will decide where to land? I think Patrick was trying to.
So to decide, they have to look all over the planet to see which areas are smooth. If it's a smooth area, it should land in that area. If it's rough, it should continue searching. If it runs out of fuel while searching, it will stop. It will use its rocket boosters to slow down while it's using solar power to recharge. And when it's recharged, it will continue searching, and eventually it'll find a spot that is smooth for the spacecraft to land. And it'll land in the smooth areas.
Yes. Okay. Yes, of course, we need to find like a safe place, smooth area, so we won't damage our rover. Owen, I saw you had your hand up, maybe? No. Okay. So first thing we want to, it's usually engineers, okay? Engineers are asking the scientists who will decide where to land to select a specific area around the equator, okay? 30 degrees north, 30 degrees south. And this is usually, we can go farther north or farther south, but usually in this area, okay, it's very important to get, you know, we talk about solar panel. Hebe, I can see you want to say something?
When you're deciding to land on a planet, even if it is smooth, it could still be not firm. You need to find a part where the ground is firm enough to have something land on it.
Yes, that's exactly correct. And
because this could be a planet like one of the gas giants, and if you landed something on it, it could be perfectly smooth 1 minute, but your rover just goes straight down into it.
Exactly. And so this is what Evie is saying is really important. So I don't know if you remember yesterday when we were talking about spacecraft and instruments. So we send instrument to study the surface of a planet. So we can, using different type of instrument, camera, the infrared, we can get information about the surface, and we can say, this is a rocky surface. Here is no rock, it's not, let's say solid, it's not firm, you know, we cannot land, or here there's ice. So we can do this activity before landing. So we study the entire planet to then start pinpointing potential landing site. That's absolutely correct. Another thing I was mentioning, we mentioned the importance of solar panel to get the energy from the sun. Another very important thing for engineer is the temperature on the surface, because instruments are really sensitive to temperature. If it's too cold, they will really struggle to maintain, you know, their capacity to operate. So engineer want an area where, let's say, all year around, you have, you know, guarantee this warm enough temperature, and it's usually around the equator. Okay. Then Patrick mentioned about a red area. We kind of eliminate. Okay, this area we just focus on the central part. What we are looking at is color map.
Oh, Julia, I think you're breaking up a little bit there.
Is if we follow, so the white are the very high rain, and we see here this peak. Do you know what? Oh, this is bad. Okay, I'm gonna stop my video again. Hopefully it will help a bit more. Okay, I can see Patrick. Patrick.
So I wanted to say two things. The first thing, can you repeat your question so that I can answer it, please?
Maybe let's see if she got that.
Is it me or is Patrick now?
Can you repeat your question, please? I think you made the question there, Julia. You asked the question, but I can't remember what it was.
Yeah. I missed that. I'm so sorry. Can you?
Yeah,
Hello?
I think I have a comment actually on the
I'm so
the
sorry
temperature.
for my internet today.
It's okay.
Yes.
Have you ever been in a place where it's so cold that your phone stops working? Anybody has seen that? Let me see. Check on you guys. Yeah, Rav is saying it. Was it very, very cold, Rav? Did it turn off? What happened?
It was there was snow, and then I was checking my tablet, and then my tablet wasn't turning on.
Yeah, yeah. You've never been, yeah. So and then there's also sometimes when it's so hot, maybe you left your phone outside in the sun, and then it shuts off as well. Anybody has seen that?
Yeah.
Yeah. When did it happen to you? Remember?
In the heat wave, remember that summer when there was the really big heat wave?
Yeah.
It started failing to work, and then eventually it just switched off completely.
Yeah, exactly.
In the end, we had to wrap it in a tea towel and put it in the fridge.
Yeah.
That's a good solution.
Yeah, exactly. So to me, it's actually happened the two different options, and this is something that is very critical for equipment, especially when you're landing something, Because maybe if Curiosity is just like driving around on Mars, and if it stops, then it's fine because it just stopped. Maybe if it's no big deal. But what if she's like it's just about to land and then everything shuts off? Like it's gonna crash and break, right? So the landing is really a delicate time where it's very critical, a very critical time where everything needs to be working and working as it at its best, very precisely. Very good. So if you want to continue there, Julia.
Absolutely. Okay. Am I back maybe?
Yeah, I think so.
Okay, hopefully. Okay, good. So we mentioned, yes, the temperature. So we need to select an area where we have, you know, the all right temperature for our instrument to function properly. Then Patrick mentioned, and also Hebe to some extent, you know, the terrain, okay? The elevation, we need to check where to land that is not rough, that is kind of flat. So the map you're seeing with colors, the white colors are the high elevation, and the blue, deep blue, are very low elevation, okay? So what do you think would be this white circular shape you see on the surface? What do you think those are? These are high, okay? High elevation. So these are something. Owen, you want to try to guess?
Could there be volcanoes?
Yes, exactly. These are volcanoes. Volcanoes. So we need to find a place where we have enough time to slow down our spacecraft. Okay, so we don't want to land on a very high mountain. We need more time to slow down our spacecraft. Remember, we are arriving at very high speed. We have our booster retro rockets, but we don't have infinite fuel. Okay, so we want to find a good spot where we can decelerate enough to land safely. Okay, so I'm going just quickly now to just show you how we create this elevation map. Okay, this is again thanks to some instruments we have on our spacecraft. We send beforehand, before landing something, and this is called laser altimeter. Okay, we have an orbiting spacecraft shooting a laser. Okay, I'm not going through the process now, we don't have enough time, but with the laser we can, you probably maybe have one of a laser pointer at home that is telling you how far you are from, let's say, a wall. Sometimes these are used by, I have one, sometimes I just play around. So with the same principle, we use a laser on a spacecraft to then measure the elevation of the terrain. Okay, so now what we are left is with this narrow, relatively narrow area of the surface of Mars. Okay, we remove, let's say, the area that might be too cold most of the time, maybe in the winter. We remove then the area where we don't have enough time to decelerate, and that's what we are left with. So we mentioned, Evie mentioned, okay, we need to find the right place where to land so that our rover is not in danger during the process. So we need to find a safe place where to land. But in addition to be safe, what do you think we should also looking for a landing site, you know, like scientifically speaking? So it's not, it doesn't just have to be, okay, safe. We want our rover to survive, but then we want our rover to explore. What would you what would you choose? You know, like an area, like it has to be like interesting in a way. What would be interesting for you on Mars?
Well, if I was to choose a place that I'd land the rover, do you see where there's the 4 volcanoes? Where where it's gone up to brown. I'd choose one of the smooth yellow areas to the right of that.
Okay, sounds good. And why would you choose that?
I choose that because there's a lot of things that it could check there. Like beside that, there's bits where there's like dips in the ground where there could have been a form of a stream or a river. And then there's also the volcanoes.
That's a really interesting observation you made.
You'd also want to keep it relatively on the yellow line when you're landing it, because yellow is on the 0 of the elevation meter.
Okay, so it's a good elevation, you think? Oh, can you hear me, guys?
Yeah, you're back now, but you were breaking up a little bit. Oh, Julia, are you there? Can you hear me? I'm not sure.
Hello.
Hello, I think you're back now. I'll share a video with you guys if that's okay. This is like a video of someone making another, just like showing how elevation maps work. Can you see what's happening? Anybody get, yeah? So basically the blue parts here, they're deep down, and then the more red or brownish color here would be the elevation. It's really cool to see, isn't it? It's a lot easier for us to understand how the flat map works, and how that pictures basically the elevation we have. It's so relaxing to watch, isn't it? I would play with it all day. Very good. Yeah, so the yellow area you mentioned there would be around here, would be like about 0. It's amazing how people can do these things. Julia, can you hear us now? Are you back? Did we lose you?
Hello.
Hello.
I can hear you. If you can hear me too.
Yeah, I can hear you now.
Hello.
If you want to continue and wrap up.
Hello.
Yeah, let's just wait another minute, and then if it doesn't come back, then we can just do this short bit tomorrow. Hi, Julia. We can hear you now. Can you hear us?
I'm so sorry. This morning I can hear you. You hear me?
We can hear you now. Yeah, if you want to continue.
Okay. I'm so sorry for this morning internet sometimes. Okay, but we are really at the end, okay? So I think we we were chatting with like stream-like features. So I guess she stream-like feature will kind of remind of maybe rivers, so flowing water. And we know water is a really precious thing we want to discover on other planets. First of all, because if we want to go and live on another planet, we need water. But also, if we are looking for life on other planets, we know that water, for the type of life we know about, water is really important. Okay, so that's a really good observation. And this is actually what the Perseverance mission looked at: evidence for past flowing water. So here to the left, we have just a close-up image of the landing site of Perseverance. Okay, I don't know if any of you read about the area where the rover landed. And if you look at this image, okay, this is like a black and white. So we don't have any reference about the elevation of the terrain, of the geology. And also Evie was saying it's important to know the type of terrain. Is it soft? Is it hard? But by looking at this black and white image, we are already able to distinguish different type of terrain. Okay, we have some terrain that look smooth, a bit darker. Some other terrain look like with stream-like features. Okay, it look like also kind of a flower. Okay, and then we have some other bit, they look a bit rougher terrain, and maybe they look like a cliff, and in between maybe this might be a valley. Okay, bending around. So what does this remind to you? We have a valley that carved into maybe like a relief, and then we have something that remembers of like stream. Does this look to you a place where water was present at some point?
Yes.
Yes, exactly. So probably there was a lake in here, and when you have a river entering a lake, so there is a sort of clash, okay, crash. It's not as hard as crashing, you know, a spacecraft, but the river is entering a lake, and so it's slowing down. And if a river slows down, he is not able to carry you know, sediments, pebbles, grains. He will just drop them that we now see on the surface that we call delta or fan. Maybe some of you heard about that. And so by doing this type of observation, okay, just visually, we can put some colors on our map and say, okay, here in blue, I just identify the area where we have these stream-like features. In this pink, I just color this darker pink. I'm going to put something that looks like maybe a mountain. Remember, we are inside a crater, okay? So this was probably the edge of a crater. So you see how important are the previous missions of the planet, so to decide where to land, to create a story, in this case, a story of water, and which is the, let's say, main goal for the current missions, you know, searching for water. Okay, I think, okay, that's just showing you where Perseverance, okay? this is a summary of what we look at today, and I hope it will remain with you at least. The different type of space mission. We talk about flyby, orbiter, and then lander and rover. Okay. We mentioned soft landing on Mars, which means let's not crash our rover and spacecraft. Okay, let's land safe. And we mentioned the entry, descent, and landing operation. And then finally, we look at choosing a landing site. And summarizing, you know, we need to find a safe place, but also interesting. Okay. I think now, if maybe in 5 minutes, if I still have 5 minutes, I should kind of try to guide you to the activity you may want to try to do today if you have time. I saw on the poll we had at the very beginning, you consider the yesterday activity easy. And I think this one, it would be a more challenging one, okay? But I'm pretty sure we will manage to do that. Okay, you will find this website on the summer camp website. So you will find the link. Is a Mars trek. So, you know, like exploring the surface of Mars. This is a NASA website. If you see top left, we have this data button. If you click on it, we have a left panel opening. We have a list already for us available, okay? And you can scroll with your mouse up and down. Straight away, we have some landing site, and we have Perseverance landing site. So it would be nice if we go and explore the landing site, okay? So if we click on it, Perseverance landing site, a new panel open up, and we have some description, okay, of the mission. On the top, we have, let's say, a reference image, okay? We can maybe see what it looks like a crater. It's probably is very old, so it's been eroded away. Can recognize the structure we looked at just a few seconds ago. So here at the bottom, you have another button you can press onto, and it says fly to area. So if you click on that, boom, you are just sent to the Perseverance area. Okay, it doesn't look great, and closer and closer, and you can start appreciating incredible levels of details of the surface. Okay, so for you to have reference area, there is another button here, the green one. If you press add, okay, you are adding it to your list. And it would be here, okay, in layers. But by pressing add layer, you will then have a list of yellow points appearing, okay, which are called points of interest. And you have a list left. So you can click about all the things we went through today kind of quickly, more about the landing process, or maybe the delta we mentioned. We have more image, okay, and you can find more about that. So if we close now all this window, if you press the red X here, the points will remain, so don't worry. So what I will ask you to do is actually doing some measurements now, okay? In the menu button to the top right, we have two two voices, let's say, calculate distance and calculate elevation profile. So to calculate distance, you then will have this window opening. You can just click on line, okay? You can go closer, and you can, if you click and drag, you are going to create a yellow line, okay? And this yellow line will just tell you the distance of your line, okay, on the surface of Mars. I think, okay, it's almost 70 kilometers, okay? So you can start taking measurement. You can maybe measure how large is the crater, if you're able to identify the crater, or maybe you can measure how long is the delta. Another very interesting tool in here is the elevation profile. So you click on elevation profile, you press line. In the same way you trace the line, you can create your elevation profile. You can see how the terrain is changing elevation. So in the same way, you click and drag your mouse. Let's say I'm gonna do it next to the previous line. You release the mouse. Now you say I'm calculating, okay? It's telling us the distance, 70 kilometers. We click submit. And in a few seconds, a bit more. I think my internet is a bit slow. I'm pretty sure your internet will be much better. Okay. Look, we are given what is called a profile, elevation profile. So if you move along this blue line, can you see the yellow dot moving along the yellow line? So this is of the surface. And so in this way, you can actually recognize, I think, the shape of the crater. You see, we have a rim and then it goes down, okay? This is the excavation created by an impact long ago. So this is the type of activity I would like to maybe using this final slide, okay? And maybe your geological friends, this slide with the color, you can maybe trace the ancient rivers or things like that. And then using the instrument on the website, maybe you can take some measurement, you can create your map and maybe adding to your map, you know, this elevation profile to be a bit more like a planetary geologist this time, and to maybe place some of the information you find about your mission, okay, saying this is a delta and things like that. This might be a bit more complicated, but I'm pretty sure you would be able to do that. And I hope you will have fun with that. Slow down a little bit, but I hope you were able to not to miss anything about mission.
Very good, guys. Thanks, Julia, for today's lesson. It was really insightful. I hope you guys have enjoyed exploring Mars and learning all about these missions, how to get there. For the post-lesson activity, as Julia mentioned, you guys can go to the website Track NASA. So this is the platform. You have the link here, and then there's also an activity sheet here to guide you guys. So maybe if you missed anything or if you're confused how to use it, you can just use this as a guide, okay? If you have any trouble, just let us know. But hopefully it's going to be very clear to you how to do it, okay? So I see you tomorrow for our final lesson. I can't believe it. And Jack's going to be back with us as well. So very exciting times. Very excited for that.